The point of contact of a circle is only one if the length of the perpendicular as well as the radius of the circle are same. The circle here and a straight line is passing inside the circle. And that means it is touching the circle at 2 points, that is A and B. The point of contact of a circle is only one if the length of the perpendicular as well as the radius of the circle are same. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidyashram, the Temple of Excellence, Mysuru. In today's session, we will be discussing about the point of intersection of a line and a circle. So based on the pointer section or a point of contact of a circle and line, so we have various conditions to be solved. So let us see and learn about the point of intersection of a line and a circle today. So first, point of intersection of a line and a circle. So when a line is intersecting a circle, we have generally three cases. The first case is discussed here. So you can see the circle here and a straight line is passing inside the circle. And that means it is touching the circle at 2 points, that is A and B. So as shown in the figure, the line cut the circle at 2 points A and B. In this case, the length of the perpendicular is always less than the radius of the circle. So you can observe the radius of the circle from here, it is maximum. So you can see here, the length of the perpendicular, that is P, is always less than the radius of the circle. When it is in this case, it means the line is intersecting the circle at two different points. The second case, you can see here, the line is touching the circle exactly at one point A. So, whatever the length of the perpendicular may be, it is same as the radius. So, if the circle have only one point in common, in this case, the length of the perpendicular from the center in length equal to the radius of the circle. So, this is possible only when the line touches the circle at only one point. The point of contact of a circle is only one if the length of the perpendicular as well as the radius of the circle are same. The next case here, you can observe we have a circle and we have a straight line which is below the circle. Here, if you observe the radius of the circle as well as the perpendicular distance from the center of the circle, P is maximum than R. So, in this case, the length of the perpendicular which from the center is always greater than the radius of the circle. So, here the circle do not have any point of contact with the straight line. So, whenever your P is greater than R, there is no point in common with the straight line and a circle. When R and P are same, you have one point in common, and when R is greater than P, that is radius is greater than the perpendicular distance, you have 2 points in common, that is you can call it as a chord of the circle. So here we have an important observation, that is when a tangent to a given circle is that the length of the perpendicular is equal to the radius of the circle. Whenever the length of the perpendicular is equal to the radius of the circle, when a straight line touches the circle, it is called as the tangent to the given circle. Here we have some important note which we have already learnt in our previous session. It may be useful for the problematic purpose. So the length of the chord of the circle x square plus y square plus 2gx plus 2fy is equal to 0. When it is intercepted by x-axis, it is 2 square root of g square minus c. Next, again the same, the length of the chord of the circle when it is intercepted by y-axis, it is 2 square root of f square minus c. Third one, length of the chord when intercepted by a straight line, it is 2 square root of r square minus p square, where p represent the perpendicular distance or length of the perpendicular from the center of the circle. Few more important conditions to remember. Whenever the circle touches the x-axis, it should satisfy the condition g square is equal to c. That is, the square of x coordinate must be equal to the constant c. Next, the condition of the circle when it touches the y-axis, f square must be equal to c. That is, coordinate y of square of it must be equal to the constant c. When it touches both the coordinate axis, then it should satisfy this condition, that is g square is equal to f square is equal to c. So if I show it diagrammatically, it may be like this. A circle is touching the x-axis here, so that then it must be g square is equal to c. If it touches the y-axis, then it must look like this. If it touch both the coordinate axis, then it should look like this. That is, both g square, f square must be equal to c. If these conditions are satisfied, then we can say it touches x-axis, or it touches y-axis, or it touches both the coordinate axis. Next is tangent to the circle. As I said, a line which touches the circle at only one point, it is said to be the tangent to the circle. Let us take few problems now. Show that the line 3x minus 4y plus 6 is equal to 0 touches the circle x square plus y square minus 6x plus 10y minus 15 is equal to 0. So whenever we have a circle and a straight line which is touching the circle, what is the condition? So that it touches the circle. It touches the circle means it is a tangent to the circle. When we say the circle or a straight line is a tangent to the circle when the radius of the circle is equal to the length of the perpendicular. That is, we have to prove that r is equal to p. So for that, let us find both the radius and the perpendicular distance so that they are equal. Then we can conclude it touches the circle. First find r. We know that r is given by the formula g square plus f square minus c. Now, what is g here? It is minus 6 by 2, which is minus 3. What is f here? It is 10 by 2, which is 5. And the c is minus 15. Substitute in the given equation. It is minus 3 whole square plus 5 square minus of minus 15. So, 9 plus 25 plus 15, it is root 49. So, therefore, r is equal to 7. Take only the positive quantity because we are dealing with the distance. Next, let us calculate the perpendicular distance. ax1 plus by1 plus c divided by square root of a square plus b square. So, here a, b, c represents the coefficients of the straight line. And x1, y1 must be the center of the circle. So, here let us see what is center now. Center is minus g comma minus f. So, therefore, here minus g means it is 3. Minus f means it is minus 5. So, let us substitute the values here. Value of a is 3. So, it is 3 into 3 plus value of b is minus 4. So, it is minus 4 into minus 5. Value of c is 6. So, it is plus 6 divided by 3 square plus minus 4 whole square. So, next 9 plus 20 plus 6 divided by square root of 25. So, this is modulus of 35 divided by 5. So, therefore, here you will get p is equal to 7 because 5 ones are 5 sevens are. Now, you can see r value is same as p value. So, since length of perpendicular, so length of perpendicular is equal to radius of the circle, I can conclude that the circle or the line touches the circle. So, because the length of the perpendicular is same as the radius, that implies the line touches the circle. Next question, Find the value of k such that the line 3x minus 4y plus k is equal to 0 may be a tangent to the circle x square plus y square is equal to 25. So, this is possible only when length of the perpendicular is equal to radius of this circle. So, since for the given condition here P is equal to R. So, first let us find P here. Get P, we need the center of the circle. Here the center of the circle is 0, 0 and radius is R. So, therefore, here it is ax1 plus by1 plus c divided by square root of a square plus b square, and R is 5 here because this is of the form x square plus y square is equal to 5 square, where center is 0, 0 and R is 5. So now A, B, C are the values of coefficient x, y and constant. So it is 3 into 0 plus minus 4 into 0 plus k divided by 3 square plus minus 4 whole square, that is equal to 5. Here substitute the square root. So it is k divided by root 25 is equal to 5. If you remove the modulus, it becomes k divided by 5 is equal to plus or minus 5. So, k is equal to plus or minus 25. So, the k may take the value of plus 25 or minus 25. Next question. Find lambda if the line 3x plus y plus lambda is equal to 0 touches the circle x square y square minus 2x minus 4y minus 5 is equal to 0. So, whenever the standard equation is given, find the center and radius first. So, here center is minus g comma minus f. So, if you want g, it is minus 2 by 2 which is equal to minus 1. If you want f, it is minus 4 by 2, it is minus 2. So, therefore, c is equal to minus 5. So, minus g is 1, minus f is 2. So, center is 1, 2. Now, we want radius. It is square root of g square plus f square minus c, which is 1 square plus 2 square minus of minus 5. So, now we have 1 plus 4 plus 5. So, which is root 10. Now, we need the perpendicular distance because they have said the line touches the circle. So, since P is equal to R, that is modulus ax1 plus by1 plus c divided by square root of a square plus b square is equal to root 10. Now, substitute the values. A is 3, x is 1, b is 1, y is 2, c is lambda there, and this is 3 square plus 1 square. Square root is equal to root 10. Now here it is 3 plus 2, 5 plus lambda divided by 9 plus 10 is root 10 is equal to root 10. Now if you remove the modulus, it becomes 5 plus lambda by root 10 is equal to plus or minus root 10. Now cross multiply, it is 5 plus lambda plus or minus 10. Lambda is equal to plus or minus 10 minus 5. So therefore, lambda is equal to plus 10 minus 5, or minus 10 minus 5, it is minus 15. So lambda may take two values, one is 5, another one is minus 15. Next question. Show that the circle x square plus y square plus 4x minus 3y plus 4 is equal to 0 touch y-axis. If the circle touch y-axis, what is the condition we have to take? That is, if it touches the y-axis, then f square must be equal to c. So first, find out f. So from the equation, we have f is equal to minus 3 by 2 and c is equal to 4. Next question. Show that the circle x square plus y square plus 4x minus 3y plus 4 is equal to 0 touch x-axis. Now whenever the circle touches x-axis, what is the condition we required? That is, we have to show that g square is equal to c. So first find g. So we have G is equal to 4 divided by 2, which is 2 now. So what is G square? That is equal to 2 square, which is equal to 4, and we have C is equal to 4. So therefore, we got G square is equal to C. Hence, we can conclude the circle touches the x-axis. Next question, show that the circle x square plus y square minus 2x plus 2y plus 1 is equal to 0 touches both the coordinate axes. What is the condition? All G square, F square and C must be equal. Now, G is minus 2 by 2, which is equal to minus 1. F is 2 by 2, which is equal to 1, and C is equal to 1. So, here G square is 1, F square is also 1. So, therefore, G square is equal to F square is equal to C. So, it is touching both the coordinate axes. Next question. Find the equation of the tangent to the circle x square plus y square plus 2x plus 4y minus 4 is equal to 0, which are parallel to the line 5x plus 12y plus 6 is equal to 0. Now, the condition is this, that is, we have a straight line which is touching the circle, that is a tangent. Now, we have to find the equation of this tangent, but tangent is parallel to one more line and the equation of the line is 5x plus 12y plus 6 is equal to 0. We have to find the equation of the tangent now. We know that two lines are parallel, their equation can be written in the form, if one equation is ax plus by plus c is equal to 0, other equation only the constant value changes. That is k. So, then only we can say two lines are parallel in terms of equation. So, the value of ax and by will be same, only the third value will change. So, therefore, I can take the equation of the tangent as 5x plus 12y plus k is equal to 0. And we have to find the value of k now. How to find it now? We have tried to find the value of k by finding the radius is equal to perpendicular formula. So, first find the center of the circle, then radius of the circle, then perpendicular distance. We can find the value of k. Substitute the value of k, you will get the equation of the tangent. So, for that, first find the center now. Center is minus g comma minus f. So, on solving, I will get g as 1. So, center is minus 1, f as 4 by 2, which is 2, and minus f is minus 2. Next, radius. So, for the radius, it is g square plus f square minus c with the square root. So, it is square root of 1 plus 4 minus of minus 4 is 4, which is root 9. So, therefore, the radius of the circle is 9. Now, we know that P is equal to R, that is ax1 plus by1 plus c by root of a square plus b square is equal to 3. Now, the equation of the straight line is 5x plus 12y plus k is equal to 0 because we are finding the equation of tangent. So, here a value is 5, b value is 12, c value is k. Center x1, y1 is minus 1, minus 2. So, therefore, it is 5 into minus 1 plus 12 into minus 2 plus k divided by 5 square plus 12 square where the square root is equal to 3. So, this minus 5 minus 24 plus k. So, it is root of 169 which gives to 13. Is equal to 3. Now, we have this as minus 29 plus k divided by 13 is equal to plus or minus 3. So, minus 29 plus k is equal to plus or minus 39. So, therefore, k is equal to 39 plus 29 and k is equal to minus 39 plus 29. So, this implies k is equal to 68 and k is equal to minus 10. So based on the value of k's, we will get two equations. So we have considered the general equation as 5x plus 12y plus k. So substitute the value of k. So therefore, the equation of the tangents are, since we have two tangents here, one is 5x plus 12y plus 68 is equal to 0 and another one is 5x plus 12y minus 10 is equal to 0. So find the value of k, substitute the value of k to get the equation of the tangent. Similarly, we can find the equation of the tangent when it is perpendicular to the given line. So what happens when it is perpendicular to the given line? So the same application, if we have a circle here and we have a tangent but it is perpendicular to some straight line whose equation is given in the form of ax plus by plus c is equal to 0. And here we will find the center, that is minus g comma minus f, and later we will find r. To find the perpendicular distance, I need the equation of this tangent, but I only know the equation of the perpendicular line which is perpendicular to the tangent. So interchange the coefficients of x and y. So this is bx plus ay. Also change the constant value to k. So consider this as the equation. Apply the same, that find the center first, then r, then p, then you can find the value of k, substitute, you will get the two tangent. Whenever the lines are parallel, only the third value will change. When they are perpendicular, if one equation is ax plus by plus c is equal to 0, other equation can be written as bx plus ay plus k is equal to 0. Find k, substitute it back. Next question. Show that the line 3x minus 4y minus 20 is equal to 0 touches the circle x square plus y square minus 2x minus 4y minus 20 is equal to 0, and also find the point of contact. So to show that this line touches the circle, radius must be equal to the perpendicular distance. So first find the center and radius of the circle. So center is minus g comma minus f. So we get minus 2 by 2, which is g. Minus g is 1. Minus 4 by 2 is minus 2, which is f. Minus f is 2. So center is 1 comma 2. Next, r is root of g square plus f square minus c, which is 1 plus 4 plus 20, which is 25, whose value is 5. Next, find the perpendicular distance, that is ax1 plus by1 plus c divided by root of a square plus b square. So a is 3, x is the center 1 plus b is minus 4, x is the second coordinate 2 and c is minus 20 divided by 3 square plus minus 4 whole square. Modulus we take here. So that is equal to 3 minus 8 minus 20 divided by root of 25. So which is equal to minus 25 by 5, which is 5. Minus 5 can be written as 5. Now p is also equal to 5. So whenever r and p are equal, so we got p is equal to r. So therefore the line touches the circle. Now we have to find the point of the contact. To find the point of the contact, that is, we know the diagram will look like this. The line touches the circle and we have a radius. So we need to find the point of contact, that is this one. So radius is perpendicular to the line. So let us find the radius equation, that is the general form of this straight line as radius. So I already told you that whenever two lines are perpendicular, when one equation is ax plus by plus c is equal to 0, the other equation is bx plus ay plus k is equal to 0. So therefore, let the equation of one line is 3x minus 4y minus 20 is equal to 0. 3x minus 4y minus 20 is equal to 0, and other line, that is the radius which is perpendicular, have the equation 4x plus 3y plus k is equal to 0. So now the equation of the radius is this. Since I'll take this as equation 2 and this as equation 1. Since equation 2 passes through 1, 2. What is 1, 2? Actually the center. This line is passing through this point, then it must be the solution of the line. So substitute here. So 4 into 1 plus 3 into 2 plus k is equal to 0. So we have 4 plus 6, that is 10. So k is equal to minus 10. So the equation 2 implies 4x plus 3y minus 10 is equal to 0. Now take this as equation 3 because we found the value of k. Now solving 1 and 2, I can find the point of contact by having the solutions. Now solving the 1 and 3, we can find the value of x and y by simultaneous linear equation method. Then that will be the coordinates of the point of contact. So solving 1 and 3. So first write this equation now. First equation is 3x minus 4y minus 20. I'll shift, it becomes plus 20. And this equation 4x plus 3y minus 10 shift, it becomes plus 10. Now we have to solve these two equations. So for that, the constant or the coefficients of any one of the thing must be same. So I'll multiply 4 here, I'll multiply 3 here. So it is 12x minus 16y is equal to 80, and this is 12x plus 9y is equal to 30. Subtract now. Change the sign whenever you are subtracting. Cancels. Minus 25y. Or 80 minus 30 will be equal to 50. So we get y is equal to minus 2. Next, substitute y is equal to minus 2 in any one of the equation 1 or 3. So we have 3x minus 4y is equal to 20. So 3x minus y is minus 2. So it becomes plus 8 is equal to 20. 3x is equal to 20 minus 8. X is equal to 12 divided by 3. So x is equal to 4. So therefore, the point of contact in the form of x comma y is 4 comma minus 2. So here, first we are showing they are touching at one single point. To show that, I need to prove P is equal to R. For that, find the radius and the perpendicular distance. We will get the line touches the circle. Then we have to find the point of contact. To find the point of contact, I am considering radius as one more line. So to find the equation of the radius, I have interchanged the coefficients of x and y and kept the third value as k. So to find k, since radius is passing through the center, substitute it at x and y, you will get k. You will get one more equation. Solving the equation 1 and 2, I'll get y is equal to minus 2 and x is equal to 4. Writing it in the coordinate form, which gives you the point of contact of a straight line and a circle. So this is how we are going to find the length of the perpendicular as well as the length of the chord, and how to find the point of contact of a given circle in this way. In our next session, I'll take you with the new chapter. Until then, keep watching, keep learning and keep exploring. Thank you.